Welcome back. Today we start Chapter 6. Chapter 6 is ratios, rates, and percents, and today we're specifically talking about just ratios. Make sure you get this in your table of contents and be ready to go. The first thing we need to talk about is what is a ratio, and then the second thing we need to talk about is how do we write a ratio. The definition of a ratio is comparison of two quantities by division. So you may remember from previous grades that ratios do look a lot like fractions, and they actually behave a lot like fractions, but they are different in that they are comparing two different things. And so then how do we write a ratio? There's three ways that you will see them written. You will see them written using a colon. So using 2:1 would be the ratio 2:1. You may see them written like a fraction. And notice that I do not simplify that any further, that when I'm talking about a ratio, even though I have a denominator of 1, I still leave it there. So that is read like 2:1. And then the last way is to just actually use the word 2. And so all three of those ways mean exactly the same thing. Okay, in this example, we are using fruit to write each ratio in simplest form. Number 1 says to compare bananas to strawberries. And so when I look over here in my picture, how many bananas do I have? Yep, that's right. I have 5 bananas. How many strawberries do I have? I only have 2 strawberries. And so to write that in simplest form, or write it as a ratio first, I have 5 bananas to 2 strawberries. And then I look at my numbers, 5 over 2. Is there any common factor that goes into both 5 and 2? No, there's not. So that answer is in simplest form. Going on to number 2, we're comparing strawberries to bananas. Now you might say, oh, well, that's the same as number 1. But it's not, because now the strawberries come first. So I have 2 strawberries for every 5 bananas. And we know from example 1 that that is in simplest form. So 2 over 5. And then number 3, we're comparing apples to strawberries. And so this is the first time we've had apples. How many apples do we have? We have 6 total apples. And so I have 6 apples over 2 strawberries. Now you may notice that they do have a common factor. 2 goes into both 6 and 2. And so 6 divided by 2 will give me 3 apples. And 2 divided by 2 gives me 1 strawberry. So there are 3 apples to every 1 strawberry. Okay, and that's just another way to write it. Remember that there's 3 ways to write it. So this would be one way that looks kind of like a fraction, and this would be the second way using the colon. And then my last one is bananas to apples. I have 5 bananas to 6 apples. And so I look, is there a common factor for 5 and 6? Nope, there's not, so that's going to be my final answer. Here's another example where we're comparing students in a class. There are 32 students in a class. There are 24 girls. Write each ratio. Well, the first thing I'm going to ask myself is if there are 24 girls, then how many boys are there going to be? And so I take 32 minus 24, and I learn that there are 8 boys. So now I know moving forward that my class has a total of 32 students, 24 girls, plus 8 boys. And so then I look at my ratios. Number 1, girls to boys. So I have 24 girls over 8 boys. And you will notice that 24 and 8 can be simplified. And if we look for the greatest common factor, 8 goes into both 8 and 24. So I can simplify that. 24 divided by 8 gives me 3 girls. And 8 divided by 8 gives me 1 boy. And so for every 3 girls, there is 1 boy. Another thing to kind of point out again that we haven't talked about since the first slide is that it's okay to have a denominator of 1 when we're talking about ratios. All right, next one. What if I am comparing boys to girls? Okay, so I have 8 boys to 24 girls. And again, because we're working with the same numbers, we know that 8 goes into both 8 and 24. So divide 8 by 8 gives me 1 boy. 24 divided by 8 gives me 3 girls. So there is 1 boy for every 3 girls. And again, I'm just writing it 2 different ways. The first way as a fraction and the second way as using the colon. Third example is asking us to compare girls to all students. So now we're going to use a little bit different numbers here. First of all, how many girls do we have? We have 24 girls. And how many total or all students do we have? And this is the first time that we've used all students, and that is 32. So again, look to see if there's a common factor, and you should notice that 8 goes into both 24 and 32. So 24 divided by 8 gives me 3 girls, and 32 divided by 8 gives me 4. So there are 3 girls compared to 4 in the total of the class. All right. Last one, what about comparing boys to all students? Again, similar to the girls. Okay, so we're going to have 8 boys compared to a total of 32 students. And we know from the previous examples, 8 goes into both 8 and 32. So 8 divided by 8 gives me 1 boy. Compared to the whole class, 32 divided by 8 gives me 4. And that is our final answer because it cannot be simplified any further. Another benefit of working with ratios is that we can write equivalent ratios. And remember that equivalent is going to mean the same as equal to. All right, so we're just going to be writing different ratios that are all equal to each other. They all mean the same thing. So if I look at my first one, 4 over 10, because we've been working with fractions, you probably right away want to reduce that, and that is totally fine. That's going to give us our first equivalent fraction. So if I divide both of these by 2, because 2 goes into both 4 and 10, then I'm going to get 2 over 5. Okay, and that's going to be my first equivalent fraction. And now you might be thinking that, oh my gosh, now I'm stuck because I can't reduce that anymore. That's okay. When we write equivalent fractions, we can also multiply. So now I'm going to take what I know, and I know that 4/10 is a ratio that is equal to 2/5. Well, what if I multiply 2/5 by 3? I'm not going to multiply it by 2 because I just divided by 2. So now 2 times 3 will give me 6, and 5 times 3 will give me 15. And so that is a second equivalent ratio. And then the third one, I'm going to try and keep my numbers small. So I'm just going to go back to this 2/5, only this time I'm going to multiply it by 4. And so 2 times 4 will give me 8, and 5 times 4 will give me 20. And that's going to be my third equivalent ratio. And so again, those are all equal to each other, but they can be helpful to understand that they can be used for different purposes. Okay, let's go on to this next one, 12 over 3. And it's okay that we have an improper fraction, or what looks like an improper fraction. Again, it is a ratio. And so the first thing I'm going to look for is, can I reduce it? Sure, I can, because 3 goes into both 12 and 3. So 12 divided by 3 gives me 4, and 3 divided by 3 gives me 1. So that's my first one. Now, because those are small numbers, I'm going to use the 4 over 1 to write my next equivalent fraction. And so 4 times 2 and 1 times 2 will give me 8 over 2. So there's my second equivalent fraction. And then my third, I'm going to go back to my 4 over 1. I'm going to take it times 4 because, again, we already did 3. So 4 times 4 will give me 16, and 1 times 4 will give me 4. And so 12 over 3, 4 over 1, 8 over 2, and 16 over 4 are all equivalent fractions. All right, last one. We're going to do here 3 over 5. In this example, we can't simplify. That is in simplest form. So I'm just going to start multiplying. Multiply by 2, and I get 6 over 10. If I multiply by 3, then I'm going to get 3 times 3 gives me 9 over 5 times 3 gives me 15. And lastly, if I multiply by 4, both the top and the bottom, then I'm going to get 4 times 3 gives me 12, and 5 times 4 gives me 20. And those are all 3 equivalent ratios. All right, last slide is just asking us to write them in simplest form. And so if I look at my first example here, I have 50 to 15. I'm going to go ahead and write that in the form that looks like a fraction because we've been working that way. It makes it a lot easier for me. So 50, I'm looking for the greatest common factor. I think it's going to be 5. And so if I divide both the numerator and the denominator by 5, 50 divided by 5 gives me 10, and 15 divided by 5 gives me 3. And then I double check to make sure, is that in simplest form? Yes, it is. Okay. Now what about 6 compared to 4? Again, write it like it looks like a fraction, and I'm looking to see what do they have in common. They have a 2 in common, and so I'm going to divide both the numerator and the denominator by 2. 6 divided by 2 gives me 3, and 4 divided by 2 gives me 2, and we know that 3 over 2 is in simplest form. Then I'm going to look at number 3. Number 3 says 3 out of 5, and so if I write 3 out of 5, and then I look to see what they have in common, I notice that there are no factors they have in common. So that is in simplest form. And that's going to happen every once in a while where it's already in simplest form. Okay. Last one, 4 over 18. Again, looking for the factor that they have, the greatest common factor that they have. And I'm noticing that I think it's just going to be 2. So that's what I'm going to try. 4 divided by 2 gives me 2. And 18 divided by 2 gives me 9. And then I look to see 2 over 9. There are no common factors of 2 and 9, so that is in simplest form. All right, finish up your practice problems, and we'll see you in class.